Good morning, everyone. Myself, Nirmala Gandhi, and I'm working as an assistant professor in the Department of Computer Science and Engineering in KSR College of Engineering. Now I'm going to present the topic cryptography. Cryptography is a practice and study of hiding information. Generally, crypto is a Greek word which means hiding, and graphy means writing. That is a hidden writing. Uh, Two computer scientists gave two proper definition for cryptography. That is, cryptography is the science of using mathematics to encrypt and decrypt data, which is given by Phil Zimmerman. And cryptography is the art and science of keeping messages secure, which is given by Bruce Mayer. These two computer scientists are from American University, and simply cryptography means secret sharing of information. And for cryptology, it is the study of techniques for ensuring the secrecy and authenticity of information. Cryptography means that is using some techniques to hide information while sharing from one to another. No third party will use that data or read the data. And another one is script analysis, which is revealing that secret information or that particular usage of key or algorithm, that information by forging or by recovering legally, which is crypt analysis. Cryptography and crypt analysis are the two main branches of cryptology. Cryptology, it is a combination of cryptography and crypt analysis. And the main goal of this cryptography is to provide secure data while communication through any medium. That medium may be a wireless medium or a wired medium. And the cryptography provides four basic services, that is confidentiality, integrity, authentication, and non-repudiation. Confidentiality means ensuring that the data is transferring in a secret way. That is, no one can read that message without without any proper credentials. That is, if two person want to communicate data in a secret manner, means that the two alone have that message. No third party will enter into that communication and you access the data. That is confidentiality. Next one is integrity. Integrity means that is that the transferred message should not be altered or something it is deleted or some cases. That is the originality of that message is to be transferred from the sender and the receiver. That is integrity. And next one is authentication. Authentication, it provides one's identity. That is a authorized user, that is a valid user only involved in that communication. That is transferring of that secret data from a sender and a receiver, means that the sender and receiver should be an authorized one. No unauthorized person should communicate or enter into that communication without proper identity. And next one is non-repudiation. It is a mechanism to prove that the sender really sent this message, and it proves that the receiver really receives that message. That is a non-repudiation. These are the four services provided by cryptography, and the terminologies used in this cryptography are plain text, encryption, ciphertext, decryption, and key. Plain text is the original message. That is the actual human readable format message. That is the plain text. Next one is encryption. Encryption is the process of converting that plain text, that is the original message, into a coded message, that is ciphertext. That is in the form of scrambled one. That is, it is not it is an unreadable format, that is called as ciphertext. And the next one is decryption. Decryption is the process of restoring the plain text from the ciphertext. That is the scrambled messages again retrieved into the original format, that is decryption. For encryption and decryption, we are using an encryption and decryption algorithm along with the key. And the key is a value which is independent of the plain text and of the algorithm. Based on the usage of key, the cryptography is divided into two main subcategories, that is symmetric key cryptography and asymmetric key cryptography. That is symmetric key cryptography means that is a single key is used for both encryption and decryption process. uh, this is a general structure for symmetric key encryption. Here plain text, that is the original message, that is in left side, it is a plain text, this is the input which is fed into the encryption algorithm. This encryption algorithm receives the plain text and a secret key, that is a value which is used for converting that plain text into ciphertext. These process are takes place in the sender side. The sender's plain text is converted into ciphertext by means of an encryption algorithm which uses a key, secret key. And the receiver receives the ciphertext as input and convert that ciphertext into plain text by means of a decryption algorithm and a secret key. This decryption process takes place on the side of receiver. Here a decryption algorithm is used for retrieving purpose. Here the secret key that is used for both the encryption and the decryption. This is this is the structure for symmetric key encryption. And this symmetric key encryption is also called as secret key encryption or cryptography or conventional cryptography. Here a single key is used, a common key, that is single key is used by both the sender and the receiver for encryption and decryption process. Several encryption algorithms are used for this conversion process. And the main advantage of this symmetric encryption, it is easy to design, that is it is simple, and it is and its execution time it takes less, so it is a faster one. It also has a disadvantage, it has less security, it is a less secured one because of the single usage of key and uh, same type of algorithm. So that is two main algorithms here are that is attacks here are brute force attack and cryptanalytic attacks. And the symmetric key encryption, some algorithms are DES, that is data encryption standard. And another one is advanced encryption standard, AES, we called as AES. And triple DES, blowfish, RC5, these are some examples of symmetric key algorithms. And next one is asymmetric key encryption. Here two keys are used for encryption and decryption. It is also called as public key encryption. Here, the original plain message, that is plain text, is converted into ciphertext by means of encryption algorithm and a key, that is a public key. That public key is a key which is known to everyone in that communication group. That is public key. If two person want to communicate means each and every one's public key is known to other. And private key, that private key is a secret one that is to be maintained but by that user alone. So in sender side, the sender converts the plain text into ciphertext by means of an encryption algorithm and his own public key. And the receiver receives that ciphertext and convert that ciphertext into plain text by means of decryption algorithm and his own private key. Here we are using two keys for encryption and decryption. So it is termed as asymmetric cryptography or public key cryptography. And the main advantage of this asymmetric encryption is it is more secured than symmetric encryption. Moreover, it is complex to implement. This is the main drawback. Some of the advanced encryption standard algorithms are RSA algorithm, Diffie-Hellman key exchange, elliptic curve cryptography, and in cryptography, some of the basic encryption techniques, that is traditional, that is classical encryption techniques are used here. That is substitution and transposition. These are the two traditional encryption techniques which are used in most of the encryption techniques. That is, these are the two main basic building blocks of encryption techniques. That is a substitution and transposition. That is a substitution, in a substitution technique. In a substitution technique, that is each and every characters of the plain text are replaced by some other characters or numbers or by symbols. Here, for each and every single bit of data is to be substituted by some other characters, numbers, or symbols. Next one is transposition technique. It is a permutation of plain text letters. That is, the characters are arranged in an order, and it is to be shuffled in a certain way. Some sort of permutations are carrying over there. These are the two main techniques. A substitution technique and a transposition techniques are used in this encryption techniques. And let us see a few examples of substitution and transposition techniques. So one is Caesar cipher. It is the earliest known use of substitution type cipher. The Julius Caesar uses this substitution technique at the time of his ruling period. This is the first and foremost cipher technique. That is, in Caesar cipher, each and every characters of alphabets are replaced by, that is substituted by the character which is present in the third position. That is, the alphabets, we have 26 alphabets, starts from A to Z, and in cryptography, for better understanding, plain text are represented in small letters, and cipher text are represented in capital letters. Here, we have alphabets from A to Z, and by using Caesar cipher, we are substituted by the third character which starts from A. For example, in the place of A, we are going to substitute D. That is from A to third character. That is the A is in first position, means the character that is which is in fourth position is to be substituted. For A, it is D. For B, it is E. For C, it is F. Likewise, this substitution technique goes on. After EZ, it is in a rotatory basis. That is, A, B, C are substituted. Here is an example. That is, a plain text is "Meet me after the Togo party." This is a plain text. So this cipher text is written as, for M, we are substituting P, which is the third character after M. For E, it is H, and for T, it is W. That is "Meet me after the Togo party." It is a plain text. Its corresponding cipher text is P P P H H W P H D I W H U W H K W R J D S D U W P. Likewise, we are substituting. This is the simplest and easiest form of cipher. And the next one is Playfair cipher. This is it is known as multi-letter encryption cipher. For each and every character, more than one character can be substituted. It is in the form of a diagram. In Playfair cipher, we are using 5x5 matrix for the data filling. First, the keyword first the keyword is monarchy, and the plain text is instrument. I forget one thing. See, in Caesar cipher, the key value is 3. Plain text is meet me after the Togo party, and key is 3. That is the 3. The ciphertext should be present, that is substituted after the 3 characters. So the key is 3. Next one is plain text. Play for cipher. In play for cipher, for a 5 cross 5 matrix is taken. Already we have a 26 alphabets. First, the keyword is to be filled in that matrix starts from right topmost end to left topmost end to right, and from top to bottom we are going to fill that first keyword. Here our keyword is monarchy, so I'm start from the left top corner, that is monarchy, from first cell, that is MONARCHY. Monarchy is to be first filled in the 5 cross 5 matrix, and the remaining alphabets from A to Z is to be filled in the remaining cells. Already we have A in the keyword, so left it. Next, B is to be filled in the second row. C is also present in the keyword, so we left it, and D, E, F, G are written from top to bottom and from left to right manner. And we have only 25 cells, so instead of that I used I and J in same cell for encryption. We can take either I or J for encryption and decryption purpose. And following that, KL are placed here. Next, M and O are in keyword. Following that, P, Q are placed, and R is the keyword, so we left it. S, T, U, V, W, X are in alphabets. We fill this remaining letters, and finally Y is in a keyword, and finally we put Z in the last bottom right corner. Likewise, we fill this 5 cross 5 matrix. This is the first step. And next, we have some certain rules. The first one is we have to draw the 5 cross 5 matrix, and in the plain text we have any repeating letters. For example, the plain text is hello, means we are having 2 L's. First we have to split the plain text into two characters. For example, we have instrument as input. First we have to split two characters as a set: in as a set, st as a set, ru as a set, me as a set, and nt as a set. So instead of if we have any repetitions, for example, hello is a plain text, means we have 2 L's. Between the 2 L's we have to fill a filler. And if that while splitting at the last end we have as in individual character, means we have to add a filler with that character. So first we are writing the keyword as first in the 5 cross 5 matrix, and the remaining alphabets are to be filled. And next rule is if the 2 letter set to be present in the same column, means you have to replace it by uh, the character which is beneath the plain text. And if the 2 letters, that is the 2 characters in the plain text, are in the same row, means we have to substitute as a ciphertext by adjacent right end character. And also if it is in the right end, means we have to wrap around that row. Meanwhile, the column is to be in the bottom end, means we have to wrap around that column. Moreover, and it is in the rectangle format, means the intersection point of that characters are to be replaced. uh, in play for cyber, we are taking monarchy as a keyword, and the remaining cells are to be filled with the alphabets. First, we have to split. We have to split the instrument as two characters, that is in, st, ru, me, nt, s, z. Here, in is in the matrix as in a rectangle format, I and n. The intersection point of I and n is g and a. Instead of I n, we have to replace it by g and a. and the st is to be replaced. St is present in the same row, that is in the fourth row. St is present in the same row. Instead of st, we have to replace it by t and l. T is in right end, so we have to wrap around and substitute it as l. Instead of s, we have to put t, and instead of t, we have to put it as l. And next one is R. You here in diagram, this green letters are plain text, and red cells are ciphertext characters. And R U is plain text characters, and is to be replaced by M and Z. The intersection point of R and U is M, and in second one is Z. So RU so replaced with M and Z, and M and E is to be replaced by C and L, because M and E is present in the same column. So the character which is present after the M, that is a C and L. And next one is N and T. Now the M and E are replaced by C and L, which is present in the same column. While in same column means we have to write it as beneath the characters which is present in that column. Here M and E, for M and E we are going to substitute as C and L. For N and T, last two characters N and T, we are going to substitute as R and Q as intersection points. For instrument, the ciphertext is GA, TL, MSH, CL, and RQ. And the next one is transposition technique. In transposition technique, we are not doing any substitutions one for another. One is not replaced here. Just we are writing in some sort of order, and we are reading it in some sort of order. The first one is rail fence technique. In rail fence technique, the plain text is written in a row wise manner, and first row is written in a normal way, and the second row starts from the center point of first two characters, and second character starts from second and third character center point. It's right in a diagonal way. Here the plain texters meet me after the Togo party with the rail fence of depth 2. Here two rows are used, and here this meet me is written as in first row M is used, and in second row, that is in between M and D, we are going to write E in the second row as a diagonal one. MEET, MEAFTER, Likewise, we are writing in a two row with the diagonals. Then we are going to read it from row wise, that is left to right, and from top to bottom. The ciphertext is MEMATRHTGPRYETEFETEOAAT. That is yeah, just arranging writing in one order and reading in one order. That is the rail fence technique. Next one is columnar transposition. Here the plain text is right in a rectangle way, that is in a matrix format, that is row by row and by column by column. First the plain text is right in row wise manner, that is here the plain text is attack postponed until 2 a.m. Here the plain text is written in by using 7 columns, that is ATT, which is in the first row, OSTONE in the second row, DUNTILT, which is in the third row, and WOAM in the fourth row. And finally, 3 empty spaces are here. So for filling that, we are using X, Y, and Z as fillers. Now we are writing in one order. Here the key is 4, 3, 1, 2, 5, 6, 7. Just we are reading that row by row data in column wise format. That is a TTNA, which is the third row. We are going to write it in starts from first TTNA. Next second row APTM. Second column. Third column is TSUO, and fourth column is AODW, and fifth one is COIX, sixth one is KNLY, and last one is PETZ. Likewise, we are writing in row wise and reading in column wise. Here, some sort of permutation, that is the arranging of that column is in a shuffled manner. This is columnar transposition. And these are some of the simplest substitution and transposition techniques. We'll discuss some other techniques on next videos. Thank you.